Why use GD&T? What is so special about it anyway? First off, what is GD&T? Well, GD&T stands for Geometric Dimensioning and Tolerancing. Basically, GD&T is a more practical way to communicate engineering tolerances and designs. It gives manufacturing more freedom in production while still maintaining critical dimensions. So here is a practical example. Look at the two images on the right side of the slide. This would be a typical dimensioning example. So you've got side 1 on the left and side 2 on the top. And we'll say point A, that lower left-hand corner, is our reference point. So for side 1, say the dimension is 3 inches plus or minus 0.25 inches. Because side 1 could be 2.75 or 3.25. Now think about what that actually means for side 2. Is side 2 going to be straight the whole length of the rectangle? Well, technically, with a tolerance like that, it could be wavy, like the image below. It could be anywhere between 2.75 and 3.25, and it would technically still meet the specifications of the drawing. GD&T prevents a lot of these mistakes from occurring, so look at the two images on the bottom. The image on the left is a very similar setup, except it adds in the flatness symbol for side 2. So that flatness symbol would say something like 0.05. So you would still have the dimension on side 1, 3 inches plus or minus 0.25. But then because of the constraint on side 2, the flatness being 0.05, you would get nowhere near the variance in side 2. Of course, there's always a little bit of variance in the real world, but it wouldn't be as dramatic. This helps production as well, because instead of saying side 1 has to be 3 inches plus or minus 0.05, you give production that flexibility. It can be anywhere between 2.75 and 3.25, as long as they do not vary by more than 0.05. So they get to pick that initial area between 2.75 and 3.25, but then they have to stick with it more precisely. Alright, so flatness was just one example of the GD&T symbol. One standard for symbols is the American Society of Mechanical Engineers, ASME, Y14.5 2009. So here are some examples of symbols you might see on a GD&T print. There is straightness, which is a flat line. You have flatness, which is in reference to a surface. You have circularity, which is 2D, a lot like straightness. Then you have cylindricity, which is more of a plane, like flatness. So there's a lot of similarities there. You have profile of a line, which is talking about a curve. You have profile of a surface, which is talking about a whole curved plane. You have perpendicularity, so it's looking for two things to be 90 degrees. You have angularity, so any other angle you want to specify. Parallelism, symmetry, position, you see that a lot with circles. Concentricity, so how concentrated is the circle. Circular runout, and total runout. Runout has a lot to do with when you're turning a circular object, how much the diameter varies. Something that comes up quite a bit with GD&T, and something I believe that confuses people and you really have to sit and think about for a second, is least material condition and maximum material condition, typically referred to as LMC or MMC, and there's symbols for each one as well. They're typically used when there is concern about mating parts, so two parts coming together. For a hole, maximum material condition would be its minimum diameter. That makes sense. So if you have a small hole, you have as much material as possible. So think about an object with a small hole in it. There's more material in that than if you made the hole bigger. And that can be tricky sometimes because you think big hole, lots of material. But no, because it's a hole. It's the absence of material. So least material condition would be the biggest hole possible. The bigger you make the hole, the more material you're removing. For anything else, such as pegs or pins, it's the exact opposite. So maximum material condition means a bigger pin. Least material condition means a smaller pin. So in practice, as long as the MMC of the pin is smaller than the MMC of the hole, they will always fit together. I've seen this come into play as well when the position of the hole is important, but really it's the size of it that matters. So a lot of times with MMC and LMC, you have more freedom as to where you can move the hole, depending on the hole's size. Which is a bit confusing to explain and kind of a tough concept to grasp, but it ties in with GD&T well because it's all about specifying what's really important to you while giving freedom to change other things around a little bit. So here are some general GD&T rules, and there's a lot more than this, but these are just some general rules to give you an idea of what GD&T specifies. All dimensions must have tolerances because all dimensions have variation. And that's true, everything in this world varies. Whether it is a specific tolerance for the actual dimension or the title block specifies, a lot of times you'll see in title blocks, for all dimensions without a specific tolerance, the tolerance is this. Or the dimension can have a tolerance referenced elsewhere on the print in something called a feature control frame, which is like a really technical GD&T callout, usually with datums. Every dimension and tolerance required to define the final part shall be shown. So every dimension you need to know to understand the final part, you have to show it. Dimensions and tolerances are valid at 20 degrees Celsius and 101.3 kilopascals unless otherwise stated. That's pretty much room temperature. I mean, it may be slightly different, but it's just saying dimensions and tolerances are this temperature, unless otherwise stated. So for things like jet engines or submarine parts that are planning on going to the Arctic, they're going to have to state these dimensions are based on this temperature variance. Also, kind of tying off from dimensions and pressure, unless explicitly stated, all dimensions and tolerances are valid only when the item is in free state. So it's saying, yes, here's a dimension of a part, but if you put it into a press, you're going to change that dimension. Thank you so much for watching this video. I hope you learned a lot about GD&T and why it is really practical. Not all prints even use GD&T, and not a lot of people are very comfortable with the concepts. But when used correctly, GD&T is very useful, both for design and production purposes. So if you like this video, please subscribe to Beginning Engineers. I'll be covering a variety of topics, pretty much full time in the summer of 2016. Thanks, have a great day.